Alright, so our video is about coordination compounds and naming them and then also writing their formulas. So this first one, we're going to start with looking at the ligand's Greek prefix. So on this one we only have one Greek prefix because this water is only one. So we have a 5 here, which means that it's going to be penta. Alright, next we're going to look at the ligand itself. So we have a CN and an OH2. So the first one is cyano. Second one is aqua. Because A comes before C in the alphabet, our aqua is going to be first. Alright, and then next we're going to have our transition metal, which is CO. That's going to be cobalt. And finally we need to find our oxidation number. So we know that the total needs to be -2. Water is just neutral, so we don't have to worry about that. All we're worrying about is the CN. So it has a -1 charge per molecule. So our total charge in here with the ligands is going to be -5. And we need it to get to -2, so our cobalt is going to have our third oxidation state because that is a +3 charge, and 3 minus 5 is -2. So to finish this off, we're going to have aqua, penta, cyano, cobalt, and because this is an ion and is not attached to anything and has a negative charge, it's going to be cobalt 8, and our oxidation number is 3, and finally we just have ion. So that's how you do the first one. Our next one looks like this. So again, we're going to look at the Greek prefix first, which is 6, so that's going to be hexa. Again, we have another CN, so that's cyano. Our transition metal is iron, so we have Fe. But if you look here, we only have the ion, and it's a negative charge again. So we're going to have, instead of the cobaltate that we had up here, we're going to have ferrate. And again, we're going to calculate our charge. So we have the Cn, which is a -1 charge, times 6 is going to be -6. But we need to get up to -4, so that our ferrate is going to have the second oxidation number, which is +2, and that will get us to our -4. So to finish, we're going to have hexa, cyano, ferrate, 2 ion. Alright, now we're going to do some formulas. So the same thing is going to happen. We're going to look first at the Greek prefix. So here we have tetra and di. So this is going to be 4, and this is going to be 2. Next we can look at the ligand's names. So we have amine and aqua. Amine is going to be the ammonia, so NH3. Aqua is H2O. Our transition metal is cobalt, so that's a CO. And then when we're calculating our charge, we need to remember that cobalt has a +3 charge from this third oxidation state. And then bromide will come in at the end. So to start, we always start with a transition metal. So we have cobalt, and then we have our ligands. So we have NH3. There are 4 of those. We have 2 H2Os. So we know so far that we only have to worry about this +3, and because both of these are neutral, we don't have to worry about any other charges. So our +3 is here, so this total thing is going to be +3. So that means that our bromide has to be 3 to match up with our +3, so +3 and -3. Alright, and for our last one, we're going to do the same thing just with a different one. So first we do the Greek prefix again, so hexa is going to be 6. Cyano, again, is Cn. Chromate is going to be chromium. Oops. And this is the third oxidation state, so that's going to be a +3. And then we have potassium at the front here, because this is our cation. In all the last ones, we've had cations as the actual coordination compound, so they all had positive charges, but here we're going to see that we have a negative charge, and so the potassium will come first. So when we write the formula, we're going to have K. We're not sure how many Ks we have because we haven't calculated the charge yet. So we'll go ahead and start with chromium because that's the transition metal that goes first. And then we're going to have our cyano, so we have Cn. We have 6 of those. So our chromium has a +3 charge. For each cyanide we have a -1, so that's going to be -6. So this entire thing here is going to be a -3, which means that our potassium needs to have a +3, and that's going to finish it off. So that's our